Let's slowly start with the introduction part, and then while people are joining in, we can start with the session also. So welcome again to the second edition of a September Power Platform User Group Stuttgart call. And as always, just a reminder that the call is recorded and will be posted later on to the Stuttgart Power Platform User Group. Also, you can check all the upcoming events on our meetup page. Your hosts again, like pretty much every time, myself and Christian, he'll join in a few minutes. And just to announce before we start with today's session, just to announce the upcoming events we are having in September and October. So next week, Wednesday, same time, it's Markus with us with data modeling session. Then afterwards, first week of October, it's Mark from DataMark explaining about external tools. And also you can see more details on our meetup page. So we have a pretty full schedule for entire October and November. And also for November, there will probably be some sessions which will be partially live, partially virtual. So let's see, check for the meetup for the upcoming events. And not to take too much time. So for today, our main guest, main speaker, Gerhard Brueckl from Austria. Gerhard, welcome. And he will talk to you about Databricks together with Power BI. So Gerhard, welcome, and stage is yours.
Okay, let me quickly change to present. Yeah, so let's get started. Okay, perfect. So yeah, today's session is about Databricks and how it actually interacts with Power BI. So I guess most of you are familiar with Power BI at some point because it's a Power Platform user group. But some of you may also already know Databricks. I'll also give a brief introduction to what it actually is afterwards. Yeah, so who am I? So my name is Gerhard Brueckl from Austria. I live next to Vienna. I work at a company called Pake. We focus on AI and machine learning in the Microsoft Azure platform. I am blogging, I'm on Twitter. Basically, you can see all the contact information on the screen. I also do a lot of open source coding with regards to Databricks and also to Power BI. So you will find a lot of repository and code on my GitHub repository. And there are also some Databricks specific tools for CI/CD and professional development that I'm the creator of. And recently, I also created a Delta connector for Power BI that allows you to basically connect Power BI directly to your Delta Lake tables. But that will also be covered in the last section of the session. Also, I'm Microsoft Data Platform MVP for I don't know 5 or 6 years now. And I'm actually frequently speaking at events like this and also in-person events once they are allowed again. Besides that, I'm also one of the organizers of the Austrian data community, the former PAS Austria chapter, where we also have like our regular or monthly meetings and user group meetings with various sessions, like similar to this one. Yeah. Okay, but let's get started. So let's go quickly through the agenda. So first of all, I want to give you an idea why I actually created this session and why I think it can be important for a lot of projects. Then I will give a brief introduction what Databricks is and how it works under the hoods, and then we get right into on how we can actually use the data that we create in Databricks and consume it with Power BI. Okay, so as mentioned in the beginning, we do a lot in the big data, AI, and ML area in Microsoft Azure. And in general, big data is becoming more and more important. So most of our projects, well, have the term big data in their description, even though it's not always the case. I mean, it depends on your definition of big data. But it's like a buzzword, and it's used very often, and a lot of yeah, it drives a lot of projects, let's say. So whenever it comes to big data processing, I think there is currently no way around Spark. So Spark is like the big data processing engine that basically every big vendor uses. And there is a specific implementation of Spark, which is done by Databricks, which I will also explain later. Yeah, so that's why Databricks and Spark are just very, very important in this big data area. But anyway, regardless of the data that you're processing or the amount of data that you're processing, you cannot simply visualize like a table with 100 terabytes in any feasible way. So you need to actually pre-aggregate the data to actually consume it in a reporting tool. In our case, Power BI. Also, usually if you do reporting, you usually do it on top of a, let's say, SQL database or relational database, but that's not always available. So we're actually seeking for a way to visualize the data that we have already processed in our big data processing engine without actually moving it to another layer again. And obviously, for reporting purposes and for the visualization, well, we use Power BI because it's like the reporting tool yeah, it's actually the only reporting tool in the Microsoft world, in the Microsoft ecosystem. So that's our go-to tool. Yeah, so if you have a look at a classical big data architecture or analytics platform architecture, you will at some point have some ingestion stream or data pipelines. Then you have some storage, usually a data lake store, also be a blob store, doesn't really make a big difference. You will have some processing engines. In this case, again, it's Azure Databricks. You may have an additional layer for SQL at the top for the SQL data warehouse, or Synapse as it is called by now, and Azure Analysis Services. And of course, you also have Power BI, so the actual reporting tool. And this session focuses on the point number 5, so the direct connection from Azure Databricks to Power BI. So there's no intermediate SQL layer, there is no analysis services whatsoever. We just read the data from Databricks and visualize it in Power BI. There is this dashed lines around the store or the storage also. That's basically because one of the ways to visualize the data from Databricks is also to connect to the storage itself. So Databricks itself does not persist any data. It always persists it in an underlying storage. And you can also access the storage directly without actually having to use Databricks. So basically you use Databricks only for the processing and then visualize the results in Power BI. Okay, so now I've talked a lot about Databricks, but what is it actually? So Databricks was one of the first companies that actually realized that there is a huge potential in big data processing in the cloud, especially because you have a lot of opportunities in the cloud that you just don't have on premise, especially with regards to availability of resources, storage services, and so on. So they built their whole solution in the cloud, and it's also only available in the cloud. It's available on Azure, AWS, and Google Cloud Platform, so basically all the major cloud vendors. What's very important about Databricks is that Spark, so the underlying processing engine that's used, the people that actually created Spark are also the people that founded Databricks. So Spark itself is open source, but a lot of new features first make it into Databricks before it actually makes it to the open source branch of Apache Spark. So Databricks is always on the let's say latest version of Spark and always has the latest features, which is also a very big plus when you want to use Databricks. And there has been very huge success of Databricks over the last years in all the three cloud platforms. So they are doing really, really well, and also the product is pretty good, and yeah, I really like to work with it. So yeah, then the second thing, okay, what is Apache Spark? Apache Spark, I mentioned before, is an open source project of the Apache Foundation. It's the largest Apache project that deals with data. So there is a lot of community around it. There is a lot of active contributors. It's basically evolving very fast. And the initial goal of it was to improve another technology called MapReduce. I think it was originally invented by Google. And it basically, it basically allows you to analyze data or process data in a cluster, which is supposed to scale linearly. So if you have like a terabyte to process and you run it on a cluster with 2 nodes and it takes 10 minutes, and then you can run the very same job without any modifications, take it, run it on a bigger cluster with, let's say, twice the amount of nodes, let's say 4 nodes, and then ideally the processing time also goes down by a half. So that's the basic idea. For the whole cluster management, there are various cluster management frameworks supported. It can be Yarn, it can be Mesos, but Spark also provides its own built-in cluster management. Okay, so basically those Yarn and Mesos is just if you have, for example, an on-premise Hadoop cluster, then you probably have Yarn. Then you can also run Spark on the Yarn resource manager. Yeah. One of the big benefits of Apache Spark is that it supports multiple languages. It's natively written in Scala, but also supports Java. And from my experience, actually the most used languages are Python and SQL. Python mainly for the data science and ML use cases. So it has a very strong focus on data science. And the SQL part is it's basically like writing regular SQL, but on a big data set, which is then executed by the cluster. There are various components of Spark, but in this session we will only have a look at the 2 Spark SQL and also Spark Streaming. So it's not only a processing engine that supports batch processing, but it can also do real-time processing and stream processing. Yeah, that's just a slide that I wanted to add. It's like an official slide from Microsoft. It's already some years old, I guess. But the most important thing here is that there is actually a native integration of Databricks and also Power BI. And so those 2 tools are designed to work really well together. Okay. Okay, so that's it for the start. And now let's see how we can actually connect to Databricks. So as I said, Databricks basically spins up or is based on a cluster, or spins up a cluster for you, which executes Spark. And in order to provide you the data that it has to read from the storage, it has to process the data upfront. So it basically serves as an interface between the actual data that's stored in the data lake and the consumer, which is us in Power BI. So for this setup to work, a cluster has to be up and running whenever we query it from Power BI. However, the data as I said before, is also persistent and accessible independently. So even if the cluster is not running, the data is obviously still stored in the storage, and you can also access it there. So what we will have a look at is, so basically the setup is data is stored in the storage layer. We have a compute engine in between. It can be Databricks, it can also be Synapse, it can be basically any other processing engine. And then we'll visualize the data in Power BI. As you all know, Power BI also has its, let's say, its own processing engine, which is Power Query. So we can also use Power Query to connect to the storage and use it to transform and process the data in order before loading it to Power BI. And we'll actually have a look at those two components. So if you ever wondered or ever tried to connect Power BI to Azure Databricks or to Databricks in general, there's actually 3 ways how you can do it. So as I said, Databricks itself is based on Spark, and as there is a regular Spark connector in Power BI, you can first of all use the Spark connector, which has some advantages and some disadvantages. Since I think November last year, there is also a dedicated Databricks connector that you can use, which again has some other features that the Spark connector does not have. And the third option is that you, as I said, you can just access the files or the storage directly and use Power Query for processing. Honestly, there is also a fourth option, which is a Jdbc Odbc connection. So there is a Jdbc Odbc connector for Apache Spark, and you can also use this. But it's actually quite complicated. Well, yeah, more complicated to set up than the other connectors. It's also not, it doesn't come with the Power BI installation, so you have to install it manually. Hence, I did not include it here. Okay. So in terms of features, I think the most important feature that's outstanding is, as we can see on the right, is pen, where is it? Is the Active Directory authentication. So as I mentioned before, Power BI and Databricks are both very well integrated in the whole Microsoft Azure ecosystem. So they all use the same authentication. And if you have any security defined in Databricks or on your data lake store, you can leverage this one from Power BI. So you can just basically tell Power BI to use your organizational credentials to connect to Databricks, and Databricks can also use your credentials then to authenticate you against the storage. So if you have security defined on the storage, you can also leverage that. But all this is actually only possible with the Databricks connector. There's also the screen check for the file storage access, but that's just because you can also authenticate against the storage using Azure Active Directory authentication. Okay, there is also some improvements with the latest versions of Spark that are only available in the Databricks connector. So as it is very specific to Databricks, it can make use of some of the optimizations that are done there, which is not possible with the regular Spark connector. Right now, the only downside of using the Databricks connector, or it's actually 2 downsides. One of them is that it's not supported with an on-premise data gateway. This may not seem like a huge issue, but it can be if you have very strict network and security requirements and needs to put Databricks behind a firewall or in its own virtual network. And then there can be some issues when you want to reach it from Power BI, where you would usually use a gateway, but as it's not supported with the connector, it just doesn't work. And then again, for both Spark and Databricks connector, you always need to have a cluster up and running. So, well, that's in terms of costs, that's definitely a huge disadvantage. Okay, so because like if you have a lot of data, you need a big cluster, and if you have the big cluster running all the time, it can be quite expensive depending on the cluster. Okay, so let's have a look at the Spark connector. So it basically asks you for a server URL, a protocol, some optional parameters, and then you have like the connectivity mode, whether you want to import a direct query. So both of them are supported. And once you you click connect, it connects to the Databricks cluster, and of course you need to authenticate at some point. The only way how you can authenticate is using Databricks personal access tokens. So that's basically a unique token that you can generate for your user, which you then use to authenticate. And the way you do this is that you specify the username as token, and the password is the actual token that you can generate. Okay. If we have a look at the Databricks connector, it looks slightly different, even though it's still quite similar. So we need the server hostname. That's something that you just find in the URL when you're in the Databricks UI. You will need the HTTP path, which is something that you'll find in the cluster configuration or in the cluster tags. You can also have a look at this afterwards. You can optionally specify a database. So if you already know upfront to which database you want to connect to. There is a new feature which was added recently, which is called fast evaluation, but honestly, I have not played around with this one yet, but I'll definitely give it a try in the near future. Then when it comes to authentication, you can also use username password, same as for the Spark connector. There is also a dedicated option for this personal access token where it just asks you for the personal access token, but not for a username. So basically it's the same, but it's just a nicer UI. And you don't need to remember to put token into the username. And the most important one is the Azure Active Directory. So I can use my my user that I've signed in with in my local Power BI desktop environment, and can use it to authenticate against Azure Databricks. So that's super convenient because I don't have to remember or create any personal access tokens nor anything else. And it can also use this security to access the storage if you have specific permissions defined on the storage. How do you get to this information? So how do you get the server hostname and the HTTP path? You find all the information in the cluster page. So if you go to your cluster in Databricks, you will find the server hostname, you will find the HTTP path, and you will find the protocol and everything else in this on the page. As you can see for the Spark URL, it's a bit more complicated because you actually have to combine various fields. Whereas for the Databricks connector, you basically just have to copy two values and that's it. Okay. Once you're connected, it basically looks very similar as any regular SQL database. So it gives you a set of databases, and within those databases, you have the tables. Once you click on the table, it's actually executing a query on Databricks and gives you the preview that you see on the right side. So that's just like any other regular SQL data source, let's say. Okay. So that's it for the SQL connectors, or for Spark and Databricks connector. And the third option is, as I mentioned, to connect to the storage directly. So the most simple scenario that you can think of is that you use Databricks and you process your data and store the results as a CSV file on a blob store. Obviously, you can use Power BI, connect to the blob store and read the CSV file. And that's actually a very straightforward way to do it. there is, from my point of view, not really a disadvantage of connecting to the storage, as long as you don't have any specific requirements with regards to direct query in this case. So if you need direct query, so you cannot use this approach. If you decide to go for this approach, you need to stick to a file format that's actually supported by Databricks and Power BI, because, well, obviously Databricks has to write the data and Power BI has to read the data again. Some months ago, this was only possible with CSV, JSON, and XML. However, I think in May or June 2022 this year, Microsoft finally added a native Pake Reader, which now allows you to read Pake files from within Power BI. If you work a lot with Databricks, you've probably also heard of the Delta or Delta Lake format. It's like a specific format that's optimized for ACID compliant transactions, and also supporting features like time travel and updates, deletes, etc. very easily, so that you can actually use it as it would be a SQL table. There is no native connector yet coming with Power BI, but there is also I wrote a Power Query function that actually parses the Delta table and returns all the results in Power BI. So you find all the information there. The huge advantage of using it is that you connect to the storage, not to a cluster, so you don't need to have a cluster up and running. It basically supports any storage service that's supported by Power BI, so it doesn't matter whether your Delta table resides on a blob store, on a data lake store, on an S3 storage, on a local file system, or HDFS or whatever. It just works with all of those, basically. The drawback that I mentioned before, there is no direct query, so it's input mode only. But if you have just a small amount of data that you need to load, it can be a very viable alternative. Any questions so far? Okay, perfect. Good, then let's jump right into it and do some demo. So when we want to connect to Databricks, we need to go to Get Data, click More, and basically we'll search for Databricks. So there is this one connector where you need to add this information, as I mentioned, the hostname and the HTTP path. That's both exposed in, so if I go to my clusters, I have 3 clusters here. One of them is running, it's the Databricks meets Power BI cluster. That's just for this particular session. There you can see all the cluster configuration, and under advanced options, you see those Jdbc, Odbc properties. So I just copy those to my Power BI data model. And I also need the HTTP path. And that's it, basically. I can decide whether I want to use input or direct query. I go for direct query for now. Again, it doesn't make a difference. And now we see the screen that you have already seen on the slide. So you see all the databases that are defined. And you can see the preview. So that's basically the very same that you would also see. So Databricks also provides this kind of data browser. If you go in the Databricks UI, you can go to data and basically see a very similar interface, right? If we go to the currency here, for example, it will also give us like a preview, give us the columns and some additional information. Okay, so that's pretty straightforward actually. So you just select the tables that you want, set up the relationships and everything. And especially if you use import mode, once you have loaded the data, it's actually independent of Databricks or the actual source. So once it's loaded, there is no difference to any other data source, right? If you use direct query, there are some things that you need to consider, which I'll cover later on. Okay, cool. So yeah, that's the basic connection thing. Let's start from here. So as again, switch it. As I said, when it comes to Databricks, it's usually designed to process big amounts of data. And in order to visualize those properly, you usually do not want to run a lot of queries on the data itself, but you want to have pre-calculated aggregations. However, sometimes you still need to access the detailed data. So Power BI offers two actually independent features that work very well together, let's say. So there's one of those features called Composite Models, which basically allows you to create one model and use import tables or import mode for particular tables and also direct query for particular tables. Okay, so and whatever the user selects, if he selects only data from tables that are in import mode, it can answer the query from the in-memory data that is stored as part of the data model. If the report accesses any data that's stored in, or that's from a direct query table, Power BI is actually executing a query against Databricks. Okay, so Databricks or Spark in general, or basically most big data processing engine or distributed processing engines are not really suited for low latency queries. So a query, let's say, at least takes 1 second for a very, very simple query, because it actually has to parse the SQL statement, distribute the work on the cluster, collect the results from all the nodes that process the data, and then return it back. So there is some certain overhead that comes with every query that you execute on Databricks. So it's you don't want to hit your Databricks cluster with each and every query, and especially for Power BI, which is let's say very chatty or can execute a lot of queries against the backend. You need to be aware of this. So basically, whenever you would click a chart that filters another chart or change a slice or whatever, in direct query, it would execute a query on the Databricks cluster. Okay. So yeah, so that's for the composite models. Another thing is so-called aggregations. So you can create aggregations in Power BI to speed up certain queries. So for example, if you realize that if you have a chart that displays data by day or by single day, and it's too slow, if you want to aggregate it on the month level, so for example, if that's yeah, so if you have, let's say, January, and January has 31 days, and if it takes too long to actually sum up or aggregate this data from January, from the single days of January to the total months of January, you can use aggregations. So aggregations basically pre-calculate the value of January based on the days of January, and Power BI then takes care of showing the aggregated value opposed to recalculating the aggregation from the raw values. So those are actually two independent features. So they work very well on their own, but they can also be combined, which makes Power BI really powerful in terms of processing bigger amounts of data with, let's say, the same performance that you would expect from Power BI data model. Yeah, let's have a look at this in a demo. This one. Okay, so in this scenario, I actually, where do I start? So, okay, so I do have one fact table that is partitioned, that is in direct query. So if I go to advanced, you will see that the storage mode is direct query, so it consumes no space and no memory in my Power BI dataset. It is linked to the dim sales territory that I will use for filtering. This one is in dual mode. And we do have a dim date that's also in direct query mode. Actually, sales territory can also be in direct query mode. Anyway, what I want to show is that direct query, or the implications of direct query, and also of partitions. So especially for direct query, you basically need to know the physical data structure of your table that you're accessing. So let's do a quick example. So that's for partitioning. So we have our values by year on the right side, and on the left side I do have two filters. One is from the sales territory table, and the other one is from the date table. Okay, so basically these two. Both of them filter the fact table, the partitioned one. The fact table is partitioned by sales territory key. Okay. So if I click, or if I filter by any value from the sales territory, it still takes some time because it has to execute the query on the Databricks cluster, but it returns in, let's say, 3 to 4 seconds. Okay, so that's quite okay, because it actually has to process a lot of data. If I would do the same again, the data is cached already, so you don't see anything there anymore. If I now would use another table for filtering the data, one that's not part of the partitioning key, it takes much more time. So I mean, it's still okay. It takes about 8 or 9 seconds. But you realize that there is actually some performance implications. So that's simply because if you filter, or if you run a query against a Databricks table and you do not hit any of the partitions, it actually has to read the whole table. Okay, because otherwise it wouldn't know how to answer the query. So that's why it's just super important to know how your table is partitioned, and actually the partitioning of your table also has to match the let's say the query patterns of your reports. Okay. The second thing that I want to show is so-called aggregations. Oops. So we do have a fact table, it's called fact reseller. We have a dimension table, which is called dim reseller. And we do have an aggregation table that's called fact reseller sales aggregation. So what we actually want to achieve is that whenever we query our data by the reseller only, we want to speed it up. So for this, to accomplish this, there is those so-called feature of aggregations. So if you create up front a table that has everything that you need, like sales amount and order quantity, grouped by the reseller key, which is the key that links it to the reseller table, you can use this table as an aggregation table. If you right-click, manage aggregations, and then you see, okay, it provides you the 3 columns that you have, and now allows you to associate those columns two fields in another table. So my detail table in this case is the fact reseller table, the one above, and it only has the reseller key in common for the group by summarization, and it also provides values for the order quantity and for the sales amount, and those are both summed. Okay. Of course, if I could basically create an aggregation table for any level that I want. We just, yeah, can also overload your model. But for, let's say, if you have like a huge table and you need to speed it up, you can try introducing some of the aggregation tables that answer, let's say, 90% of the queries, and this should already improve the overall performance a lot. Okay, so what does it actually look like? The aggregation table. So again, we do have two values to the right, which are actually, it's always only order quantity, okay? So it's transparent to the end user that aggregations are actually used. He just knows, okay, there is an order quantity column that he can use, but he doesn't know that there are aggregations defined for it. So if I now select anything from the reseller dimension, the one that we have the aggregation created on for the reseller key, it's actually super fast because the query can be solely answered by the in-memory data model. Okay, so it's just like having everything in import mode. So the aggregation table in this case is in import mode. However, if I would filter by any value that does not hit the aggregation, for example, for any like a calendar year, you see that it's actually much slower. Okay, I mean, that's just a very basic example, but I guess you get the point what you can do. And if you have like a bigger data model, there can be much bigger performance improvements using these techniques. Yeah. What do I have there? Yeah, that's it about. So that's it for composite models and aggregations. Whenever you design aggregations, or in general connect to Databricks, it's highly recommended to use views so that you have like a dedicated layer that's only accessible by Power BI. So that helps for managing the data that's exposed to Power BI and also helps to manage security. Especially if the data is used by multiple data models or multiple Power BI models. Especially for aggregations in Power BI, you can also, so for example, if you do not have permissions on Databricks, you can also create a Power Query in Power BI that's ideally executed on Databricks. So you can also use group by and sum and whatever and filters obviously in Power BI. And ideally those are pushed down to Databricks. That usually works pretty well, but you should make sure that it's actually working. If we have time afterwards, we can also see, I can also show you how this actually works and how we can actually see whether the query can be pushed down or not. Yeah, I mentioned those also before. Just basically what it is about is know your data in terms of data volumes, in terms of partitions. It's just super important. And if you run a wrong query on Databricks or any other big data processing engine, it can really bring down the cluster. If you instead of reading only one partition, which is a couple of gigabytes maybe, you read a whole table, which is tens of terabytes, for example. So that query probably never returns. Also in terms of performance, it's usually in most of the projects that we do, we use a dedicated cluster only for Power BI, and then it's up to you to decide which size the cluster it is, which node types you use, and which configurations you use. So that's something that you need to test on your own, I guess. In general, the bigger the cluster, the faster the queries are, but also the bigger the cluster, the more it costs. So it's always a trade-off. So Yeah, that's again for the partitioning part. For just to make it more obvious. So basically, if we run a SQL query and select or filter by a key that's used for the partitioning, the engine can eliminate upfront files that it doesn't need to process. Okay, so if the table is partitioned by sales territory key, as in the example before, and I filter on a specific sales territory key, it only needs to read data from this specific folder where this data is stored. Whereas on the other hand, if you query by any field or only by a field that's not in the partition, it actually has to read all the data. And that can be super expensive. Okay, so then the last part that I want to show for accessing the data is accessing the storage. So basically, when your data is stored in the data lake store, you can connect to this to the storage using Power BI and Power Query, right? So you connect to a specific folder, then you see Pake files in there, or you see CSV files in there, and then you can just click combine binaries, and it will create a function and so on. It will allow you to load the data into Power BI. So that's pretty straightforward. And again, this works for CSV, JSON, XML, and Parquet. So these are basically the formats that are supported. If you ever need to, or if you're using Delta Lake, which is also the, let's say, default storage format of Databricks, the table is stored slightly different. So it's not only Parquet files, but Delta table also keeps a history so that you can do time travel and see, okay, how did my table look like 3 days ago? And so there is some additional information in the actual data, and basically the data, or yeah, the content is stored multiple times because there are like different snapshots. And in order to read a Delta Lake table properly, you need to implement some logic, which I actually did already, and create a function that you can use. It's on my GitHub repository, and it's also the official one, basically from Databricks. And it allows you to point to a storage location, and it parses the Delta log for you and only returns the latest version of that particular Delta table, or also any specific historic version if you use a second parameter. So that's pretty convenient, and as I said, like for this approach, you don't need to have any cluster up and running. Okay, cool. So let's continue there. So the last part that I wanted to cover is streaming. So Databricks also supports streaming, so you can stream data from Databricks into Power BI. So Power BI also has a streaming component. It's not super sophisticated, and it's actually more like a showcase than anything that you would ever use in production. So I don't spend too much time on this. I'll just give you a brief demo on what it looks like. I hope my cluster didn't stop. No, okay. So basically what I did, I created a workbook, which is called a notebook, which is called StreamWriter. Okay. And it creates a set of events and sends them to Power BI. Okay, so if I just execute this notebook and wait here, so that's a Power BI dashboard that's actually receiving the data from the Databricks notebook. Okay, so should update automatically. So the data is pushed into Power BI in the background, and the specific charts that are available for streaming data sets just are updated automatically. So right now I don't have to press F5 or anything. So that's just updating automatically based on the data that's pushed in from Databricks. As I said, it's like a nice showcase because you don't have to do anything. The data updates automatically, but you don't really have a lot of option when it comes to analyzing the data. So there are a set of built-in charts, for example, but there is like almost no possibility to change anything here. So basically everything that you want to display has to be in the data set. So for example, if you want to make this one a gauge chart, not a card type, but a gauge, and then I add a value and say, okay, my voltage is the value. I cannot just say, okay, the minimum value is, I don't know, like 80 and the maximum value is 100, because it doesn't support any static values. So I would need to create an additional column in my streaming data set, which has always the value of 80, and another one for the max value, which is always has a value of 100, and then I could do it. But that's not really sophisticated, right? And that basically applies to all the charts that are available. So it's, first of all, it's only a very limited set, and then those are not really configurable. Okay, but as I said, I think it's a nice showcase to see this live data being streamed into Power BI. Yeah, these are basically all the limitations that you have. So streaming, it's not a data set that you can create in Power BI Desktop, but you can only create it online. It's always a single table. There is no relationship. There is no measures. There is basically no logic. So you're really limited there. You can actually only analyze it using the dashboard tile that we've just seen, which again is very limited. However, there is this option for historic analysis in the report, like in a regular Power BI report, because there is an optional setting that also persists all the data that you stream into the service. It also persisted in a regular Power BI data model, which can then be used for regular reporting. Yeah, to create a streaming data set, you can either use the UI, but you can actually also use the Power BI REST API to create it. So if you want to automate this process, it actually works pretty well. But again, you still have all the limitations that I mentioned before. On the very right at the bottom, you see this one button for historic data analysis. That's the one that I mentioned when it comes to persisting the data also in an additional in-memory data model. You can just simply enable it, and then the data set will also show up as a regular data set. And then, yeah, well, you can create a report on top of it. What does the code look like in Databricks? So basically, when you create the data set in Power BI, it basically generates a URL for you with a specific key that you see here. So that's this URL and the key and everything that you find in the Power BI service. It also gives you some examples how you can push data or stream data into the API using a post call, either with curl or PowerShell. I think it also provides an example, and one or two more languages. What I did, I basically wrapped it into a function in Python that's then executed by the stream in Databricks. So that's the code that you see at the bottom. So I have a stream, I call write stream, and basically for each row, I call the function that I've defined above, and then I just start the stream. And that makes Databricks stream the data to Power BI to that specific endpoint that's defined in the function. Yeah, and that's it basically from my point of view for the presentation. So things that you should like remember, or your takeaways. If you don't have any specific requirements, always go for the Azure Databricks Connector. Ideally, you also use Azure Active Directory Authentication, because then you don't have to mess around with personal access tokens. For the only reason for me to use the Spark connector would be if Databricks runs in a VNet. and you actually need a gateway, then there is currently no way around the Spark connector. I don't know if the support for the gateway will be added in the future also for the Databricks connector, but yeah, we'll see. And then the third option, this file connector, I think it's still a nice option to consider, especially if your data is quite small, and especially if you don't want to have a cluster up and running all the time. Some recommendations on, let's say, the Databricks side or on the data layout side. I think you've seen in the demos that partitioning and partition alignment, partition pruning is super important. So the tables that you query from Power BI should be optimized for the queries that are actually sent by Power BI in terms of partitioning, in terms of filtering. That's one thing. If you're using the Delta Lake format, there is a specific command called optimize, which optimizes the table in terms of it rewrites and restructures the files that you get the best read performance out of it. And the last thing is that any fields that you load into that you want to load into Power BI should only be, let's say, regular fields with Scala values. There should be no complex or nested fields in there. So let me just show you briefly what I mean with this. So in Databricks, you cannot only have Scala values in a table, but you can also have so-called complex types. This can be an array, this can be a map, this can be a struct. So it looks like this actually. Okay, so these are also data types that you can use in Databricks. However, they are not supported if you load this kind of table into Power BI. So I think I have loaded it somewhere. Yeah, the complex types. So it's basically in Power BI, it would just be displayed as a long text. So, I mean, you can parse it back, but that's probably not what you want. Okay. Yeah. So yeah, that's the end of my session. If you have any questions, yeah, feel free to ask them now. Otherwise, you can always reach me, as I said, on Twitter or write me an email if you have any other questions. I'll show the initial slide again. So yeah.
First of all, thanks a lot, Gerhard, for the presentation. It was really interesting, even though I had to dial in a little bit later. It was still really valuable information. So thanks for that.
Sure.
Is there any questions in the chat?
Yeah, there is one. Is there a way to build data models calculations in Databricks, or is it mainly meant for distributed storage? So Databricks, as I said, is a processing engine, and you can also define business logic, for example, calculations in there. This can either be done in Python, but what I guess you are referring to is SQL. So you can also create SQL views in Databricks. So similar to a SQL database, if you have any specific reporting requirements and you want to provide a single table for the end user so that you can just do a select star, you can just create a view in Databricks. It's the very same statement, so it's basically ANSI SQL that you can use there, and create a view. It supports everything: group by, aggregations, filters, joins. Yeah, so that can definitely be done also in Databricks.
Is there any other questions? Somebody's typing.
Yeah. You can also unmute yourself if it's easier, or if it's a long question. Then we can discuss it.
Actually, while we were waiting, I have one question. So there is some feature in Databricks for data visualization.
Yeah.
So how is it comparable to BI, because lots of users are saying, okay, we have it there, we have somewhere, and just a short explanation.
Okay, so as you said, Databricks has its own reporting tool, which is called SQL Analytics. You still see my screen, right? Yeah. So I'm opening it just right now. So it's, from my point of view, it's like a very basic reporting tool and not really comparable. I mean, it's not super fancy charts. It can definitely be done nicer. But it's not really comparable to Power BI from my point of view. I mean, it's nice if you don't want to pay for Power BI or any other reporting tool, but I don't think that you can really create super sophisticated or reports that you would distribute to an end user. I think it's fine for monitoring purposes, for like some internal stuff, but as of now, I would probably not recommend it to have it like end user facing interface.
Thanks.
But I mean, that's my personal opinion on this one. So again, everything is executed on a cluster. You define the queries, and then within the queries, you define those queries like it's a regular select statement. You can have parameters. Group by aggregation, and that's it. You can, like, the parameters can point to like today or now or previous months, whatever. Yeah, but you definitely don't have this like interactivity that you have in Power BI with this with the snappy auto filters when you click on a bar chart and it filters all the others. Yeah, but from my point of view, that's also not how Databricks is supposed to work, because I mean, it's a big data processing engine. It's not suited for low latency queries, and so yeah.
Okay, if there's no other questions, maybe I can show the last slide again about the upcoming topics and our next sessions. So you should to see my screen again. I think, as Augustin mentioned in the beginning, on the next session, 22nd, Markus Ehrenmüller-Jensen is going to talk about star schemas and modeling your data like a star in Power BI Desktop, which is going to be a great session. And then the following one is the 6th of October with Mark talking about external tools for Power BI and how to create them. As always, again, a big thank you to you, Gerhard. And you can join us if you didn't do so already on the Power BI user group. You can see the link here, and the recording will be available on the YouTube channel. You can like and subscribe and follow along and review the whole session if there's anything that you didn't catch on first time.
Okay. Thank you very much, and see you next time. Thanks to you, Gerhard, for time and for a great presentation.
You're welcome. Thanks for having me.